Hi, I'm Vikram. Welcome to my Java video series. In this video session, we'll talk about method overloading. So, as we already discussed about the meaning of overloading, overloading is about extending the capacity of the system. So, we can extend the existing capacity with the help of this overloading. Just like when there is a capacity of 10, there is a capacity to carry 10 tons of goods by a truck, we can load there 15 tons, 12 tons, 13 tons. So we are using more than its capacity. So its capacity is just 10 tons and carrying the goods for 50 tons around. So extending the capacity. So when you see such truck, you will quickly say that it is overloaded because it is doing more than its capacity. It's doing the job more than its capacity. So it is about extending the overloading is about extending the capacity. So now just imagine in the C programming pattern. So let's take one example here from the C. Suppose there is one method here sqrt, which is calculating here square root for the double value, and there is one more method sqrtl, which is calculating square root for long double. So I have taken these two methods from the C, and these two different methods are calculating the square root, and the purpose is to calculate the square root, and we have got here two different methods. In fact, their names are different. The first one is sqrt and this is sqrtl. L stands for long. It's a long double argument, right? Suppose if we design a method like in this way, in the C programming language, what we'll do, so we have to add here two integer values. So the name is add to int. So it will take two integers, int a, int b. We have got here new requirement to add two floats. So I'm extending here, my requirement is extended to do some more job. I'm not saying that remove the previous one and add a new one. What I'm saying, keep the previous one and add new one along with that. Means the previous add two integer will be there, and add one more feature here which will do the addition for two float numbers. So this is float a, float b. So we have got another requirement now for addition. Int and float you have to add this time. So this first one is integer, second one is float. So we have got some more requirements. So what is happening here, my requirement is extending. So my requirement is extended for float and integer addition now. So you have got here new combination float a, int b. So my requirement is extending, and for that I am adding here multiple methods to do the addition. So for single purpose, a developer has to remember multiple method names. So this is the problem here. So multiple methods are there for the single purpose and their names are different. So a developer has to remember multiple names for single purpose. So I can solve this problem with the help of object oriented programming, and method overloading can sort out this problem. So now have a look at the solution. So I have provided here add method, and which is taking here two arguments, two integer arguments. So this method will do the addition for two integer values. Now my requirement is extended for two float values. So I used here a method called add method, same name I am reusing here, and I changed here arguments. So when my requirement is extended for integer and float, I provided here new method int a, float b. When my requirement is extending few more at few more extents, so I added here float a, int b. So I added here multiple methods. They will do here different calculations, and their name will be same. Now the most important part in this whole discussion is when you call this add method. So this is my method call statement. So I have to call through the objects and all. So we'll do that part in the code. But here I'm trying to show you the method call here. So when you call this add method, you need to pass here two values. So I'm passing here 10 comma 2. So these two values will be given to the method. Now the question is, you have four methods. So for this particular statement, which method will be selected for execution out of the four methods? So you need to again take a decision. So out of four methods, you have to pick one method to execute. So and this is part of decision, as we already discussed in the polymorphism introduction series. So decision is always required when you have multiple choices. So here we have uh, four choices and you have to pick one method for this method call. So when a particular method definition is selected for execution, that is called a binding. So binding is the most important job you required here, which is actually your decision part. So out of four method you have to bind with the one method. So what do you mean by binding? Binding means this method call will be linked to the method definition, or it will be linked to the method body. So method body will actually do your job. So linking this method call with the method definition is called binding. And now who will be responsible for this binding? Who can do this binding job? If this binding is done by the compiler, then it is a compile time binding. But if this binding is done by Java virtual machine at runtime, it will be the runtime binding. So here in my case, method overloading is a compile time binding, because compiler is capable to select one method out of the four methods. So there are certain rules followed by the compiler to do this job. So the most important term in this overall discussion is this binding. This is actually a decision. Who will select the definition? Who will do the binding? So binding means link this method call with its definition is a binding, and who will do this? Either it will be done by compiler or it will be done by JVM. We have two entities to take this decision, compiler or JVM. So here in our case it is done by the Java compiler. Java compiler can do this job. So Java compiler is doing this job with the help of certain rules, like compiler is always checking for the number of arguments, how many arguments you have been passing to a method. Like this, I'm using here two arguments, right? Then compiler will check for the types of the argument. My first argument type is integer, second is integer. Yes, great, right? Compiler can also follow the order. So the combination int float, then float integer, both are different combination. So sequencing or ordering of the argument is very important, right? If any of the rule is not applicable from 1 to 3, and this fourth rule can also work. It's an implicit calling rule. Like let's have one example here. So when you are passing here 10 comma 20, the first method will be called because their argument type is matched here, number of arguments are matched here, and type is matched here, and their sequence is also matching here. So first method will be called and it will produce the output, right? When you pass here 10.02 and this is 10.05, this will be the error, because by default this 10.02 is a double value. So when you are not writing here f, it is a double value, and there is no such combination available which is taking here two double arguments. So there is no such option available here, so this will be the error. To correct this, you have to use here f. So this is making your float literal. So this float value will be given to the second methods. I wrote here 2 means this is second method, right? Similarly, when you write here 10 comma 10.05 f, so this is integer, this is float, and this is third method int float combination. This will work. And now when you are passing here character A comma character B, so inside the single quote it is a character, right? So character A and character B, is there any method which is taking character values? No, there is no such combination available for characters. Now there is one fourth rule working here. So we have a fourth rule here which is called check for possible type conversion, and it is working on the rule implicit typecasting. So implicit casting means you can easily pour the water from small container to the large container without any losses. For example, you have a container, you have some water in a container capacity 1 liter, right? And you are trying to pour the water in 4 liters container. 4 liters container is larger than 1 liter container, so you can quickly do this without any loss. So from small container to large container you can quickly pour the data, you can pour the water. So the same way implicit conversion works. Means implicit conversion means small to large. So in this case you will never see any losses. So here when you are talking about the characters, characters are 2 bytes in Java. Each character 2 bytes. Each character takes 2 bytes in Java, and characters are all represented by the ASCII values internally. So all characters are internally represented by the ASCII value, which is an integer value. So here the fourth rule will be applied, and this character will be converted into the ASCII value, which is integer, and then the first method will work. So this character will be applicable for the integer, and the second argument again b is character, and which is again converted into the integer form. So the integer value for this capital A is 65 and 66 for B. So ASCII value you can check here, capital A, and a capital A is 65, this is ASCII value. Similarly B is 66 and small a is 97, and enter key in your keyboard is 10, right? So these are the different ASCII values. In fact you can check the complete series from the internet. So that's fine. So here when there is no combination available, compiler will try to follow the fourth rule, and which will follow the implicit conversion rule. If it is matched, then the appropriate method will be selected. So these are the different rules used here. The similar method overloading technique is followed by the constructor overloading also. So there can be multiple constructors in one class, and they are working on the similar rules. So these similar rules I discussed here 4 different rules, and these 4 rules are applicable on the constructor also, right? So now let's have one simple example to understand this. So I'm going to close my previous programs, and here I'm going to create here a simple example to talk about the Kelsey, and here I'm talking about the polymorphism. I'm going to discuss here polymorphism application, and basically it is method overloading I'm going to discuss here. You can provide here main class. So my main class is test method overloading. So this is my main class, and here I'm going to create another class. Just a minute, let me organize this. I'm going to create a class here Kelsey, and I will add, let me add a method here, void add. So a very simple example, integer a, integer b, and here I'm going to write a small message here. Look at this. This is add, this is integer combination and int combination. This will be printed here. Now look at this, a plus b. Okay, let me run this, then I will come to the modification. Okay, so I'm going to create here Kelsey object in main. So this is how I can create the Kelsey object. Now c dot call the method add 10 and this is 20. Now run this. What will be the output? You can quickly check, right? You will see here 10 and 20. This is not actually sum, so sum should be actually 30. 10 plus 20 will be 30, but I'm getting here 10 and 20. Actually it is doing concatenation, so you have to do here a small change. So this will be your concat. Just a minute. So you have to do here a small concatenation, right? So this bracket will be solved first, okay, then it will be concatenated. So anything when you add with this string, anything when you do the plus with the string, you will get the end result string. So that's the reason actually you could see here this 10 and then 20. So this is actually string. When you do something plus in string, it will be again string, and then you again did the plus with the 20. So the everything is converted into string form. Now it will work, okay, right? You will get here 30. Now it's time to do the overloading. I'm going to create here one more method, add, and this time this will be float. I will take here float combination as I discussed in this slide. This is float combination I'm going to show you. So these are the float things. Let me run this. C dot add. When you do here float values 10 point, suppose I'm taking here 05 and this is 20.05. This will not work. Why? Because it is a double value. So this is your double value by default. So we have two different data types in Java for floating values. One is float, single precision data type, where you can take up to 7 digits after decimal point, and we have one more data type here which is double, which is taking up to 15 digits after the decimal point. So this is not actually possible to keep to pass the uh, large values to the small container. So float is just a small container of size 4 bytes. So in 4 bytes container you cannot copy the value which is of size 8 bytes. 8 bytes are larger size, which is not convertible into small container. So this is wrong. So you have to make it, this is error. So this is your error. Compiler will show you one error. This is not possible, but you can do this. When you write here, just a minute, when you write here float, you can make it float. This is float literal. You can use capital F or small f, both are correct. So you can see the result here, something you can see here. So this is the way. Now let's talk about the another method here. I'm going to add here one more combination. So this is my integer then float. This is my int, this is my int and float combinations I'm going to use here. C dot add, I'm going to add here C dot add, this is integer value and this is 10.10.20. Okay, fine. This is float. You can see here results. The third method will be called here. Look at this. Int and float method is called and it is calculating here data 20.2. So this is the method producing the result using this third method. So when you are passing here integer and float, this will be called. When you are passing here two float values, this will be called this one. And when you are passing here two integer values, this will be called, right, extending the capacity. Earlier we required only 3 methods. Now the capacity is extended to do some more job, so you can add more methods here. That's what the meaning of overloading, extending the capacity of the class. So initially there was a single method, when and then after that we required some more things to add here, so we provided one more method. Then we extended our requirement to add integer and float combination, so we added one more method here. So this is incrementally we are adding new functionality to the class. So like this. Now I discussed one more rule here, the last rule. Suppose I'm passing here character A and character B. This is correct, and actually you can see there is no such combination for character and character, but still there is no error, and you can see the result also. You can see here result 131. So you can see here 131 because this character A is 65, it is converted into the ASCII value, and this is your 66. When you add here 65 and 66, you will get here 131. So this is how you can see the overloading. So this is a wonderful example we have done, and it's very simple example, right? So this is enough for the this particular session. In next session we'll talk about some more topic on the object oriented series. Thank you very much for watching.